is Wouter Borsboom, work for TNO, that's a research company, 3,500 people in the Netherlands, and being active in the energy built environment, and also released a white paper together internally, which can be seen about building digital twins. So we just want to start from in the Netherlands. We have serious congestion problem. So this is a map of the transportation in the Netherlands. And what you can see in the yellow one, the capacity is critical. Orange, waiting for structural congestion, and red, structural congestion, no connection to the grid. And we have two problems. One problem, so like in Amsterdam, for instance, you can get connect the heat pump, but especially to the east, we can supply energy to the PV. But that is not all. I think this is okay. You say okay, half of the Netherlands is already red, but we are only starting because here you see the growth of solar panels, and also that is supply, and then demand is the amount of electrical vehicles charging. And you see it is like exponential. And so we have a big apartment building which is sold for like €8,000 per square meter, and it's energy neutral in Amsterdam, like very good. And they will install diesel generators because they only get like half or a third of grid capacity. So maybe you don't can connect all your fancy stuff in a very expensive apartment. You have to survive. And I think this is one of the challenges. It's also mentioned, but I just want to show in the red, you see energy demand per household. And if you have a heat pump, it will be more. And the PV production in the middle. So the vertical axis, the PV equivalent hours and 74-hour time schedule. And what you see is that the most of the demand is when there is less PV, and it's the same for solar. So PV and solar is all the rest is not there as much. And when there is much production of rest, there is not a lot of demand. So I think this is one of the challenges we try to solve in the Syn.ikia. These are all the partners that want to show. And what the TNO does, we have developed a hybrid model. I think it was also mentioned by Technalia. Our experience with the sensors and the equipment we use, that data quality is quite poor. So if there is a lot of data, but the information is very few. So what we try to do is use physical models for radiation we already know. So there's solar radiation, so we know it's heating up. So we use all the physical models. But, and for the user information, we use behavior models because there are not a lot of physical links there. We use artificial intelligence, and we combine that. And so we have, on the one hand, we have the BIM model, which we convert automatically to heat network model, and on the other hand, we use dynamic data to calibrate the models. And this is a little bit how it goes. So we have the GDXML model. You can also we can also work with like an IFC with the geometric data, and we use IDF as import file for Energy Plus to have more the relation between the equipment and the zoning. And then we automatically generate a ventilation model and a heat transfer model, which you can use for model control. I'm showing a little bit of the anti-action. So on the left side we have the building model. So we calculate the temperatures, and on the right we have the AI model, and it's the interconnection. So for the next time step, it uses the calculate indoor temperature. For instance, are people going to open the window or not? And so based on, for instance, a Markov chain we use for the window state predictor, we can estimate if the window is open or not based on the calculation in the physical model. So it's interacting quite rapidly and use better data and input. So this is a little bit of a presentation. Do I have still time? Yeah. Okay. This is a little bit. This is all open source, and we use GDXML because it was quite popular 2 years ago when we started. So you have all the open source viewers get the GDXML. What I think is quite fancy when you click on the wall or window, you can see the physical properties, so you can check quite easy if a model the GDXML model is correct or not. And then it automatically calculates the energy prediction on the indoor temperature, and we use that for our MPC calculation. So this is how our MPC works. So we have a price signal. For instance, the price signal can be the availability of solar. So based on like solar prediction, we can say, okay, that is the price signal, and we use that for our optimizer. And we have like a connection above is the like digital twin, underneath the physical building, and yeah, we will also check with the state feedback if the model is still in sync with the physical environment. I think there are a lot of challenges also we have to face. So we're going to do then in the next quarter, we're going to implement it on an apartment complex. You see the BIM files of the apartment complex. And so we're going to check it. But I think what's already mentioned by other speakers is the workflow management. So the interaction also with the consultant working with it. And another aspect is also the assurance of privacy. I think we have the excellent workshop by Pablo this morning about this. But what's really important is if we have something at DSO level or maybe a facility manager, and we see the outcomes of the model, so shut off the heat pump or just turns it on, we want to understand. So there must be kind of feedback from the model to the consultant to get trust. And also, we have also see how reliable the model is. So for instance, for gas network models, we say, okay, based on the accuracy of the sensors, we think this is the accuracy of the prediction. That's really important, but you can have like 10 good results and one bad, and people lose trust and they won't use it. So this is really important. And I think with the common congestion problem, and some people will be able to react to a certain price signal and other not. I think fairness of such an FPC and people who don't have FPC will be quite interesting. And also, I think an important aspect when we have AI or black box models or controlling such an environment, that it is fair to the users of such a model. I think that was the